Hello everyone, welcome to Mathematics Pathshala. This is Naresh. Today I will discuss this problem which came in CSIR UGC net December 2023 in part C. Let's see the question. Let n belongs to Z be such that n is congruent to 1 mod 7 and n is congruent to 4 mod 15. Then we have to find which of the following statement are true. Okay, so here what is given that n is congruent to 1 mod 7 and n is congruent to 4 mod 15. That means n is congruent to 1 mod 7 and n is congruent to 4 mod 15. Okay, now n is congruent to 1 mod 7 implies 7 will divide n minus 1. So if I put n equal to 1, then what we get? N 1 minus 1 is 0, so 7 will divide 0. So n equal to 1 is a solution of this congruent. Similarly, if I add 7 to 1, it also solution, so 8 will be also solution of this congruent. Similarly, 15, 22, 29, 36, 43, 50, 50, 57, 64, 71, these are also solution of this congruent. Okay, now n congruent 4 modulo 15 implies 15 will divide n minus 4. If I put n equal to 4, then 4 minus 4 is 0, so 15 will divide 0. So n equal to 4 is also solution, then 19 is also solution, then 34 is also solution, then 49 is also solution, 64, 79, these are also solution, etc, etc. So you can check that for the both congruents 64 is common solution. So we can say that n equal to 64 is the solution of this congruent. n equal to 64 is the solution of this congruent. Okay, so now we will put n equal to 64 in every option and check which option are true. Okay, in first option what is said that n is congruent to 1 mod 3, that means 3 will divide n minus 1. Okay, here n is 64, so 3 will divide 64 minus 1, that means 63. So 3 divides 63, so option 1 is true. In option 2 what is said, n is congruent to 1 mod 35, that means 35 will divide n minus 1. Here n is 64, so 35 will divide 63, but 35 is not divide 63, so option 2 is false. In option 3 what is said that n congruent to 1 mod 21, so 21 will divide n minus 1, so 21 is divide, here n is 64, so 21 will divide 63 and 21 is divide 63, so option 3 is true. In option 4 what is said that n is congruent to 1 mod 5, so 5 will divide n minus 1, here n is 64, so 5 will divide 63, but 5 is not divide 63, so option 4 is false. So option 1 and 3 are correct option. In this problem this number 7 and 15 is very small. If the congruence is given is like this, n congruent to 1 mod say 43 and say n congruent to 1 mod say 131, in this case it's very difficult to solve in this way this problem. Okay, so in this case we will use Chinese remainder theorem. Okay, so the problem can be solved using Chinese remainder theorem. So what is Chinese remainder theorem? Chinese remainder theorem is the let m1 m2 mr be positive integers such that GCD of mi mj equal to 1 for I not equal to j, that means mi mj are co-prime and c1 c2 are be any integer. Then the system of linear congruence n congruent to c1 mod m1, n congruent to c2 mod m2 and n congruent to cr mod mr has a simultaneous solution which is unique modulo m1 into m2 dot mr. Okay, so the solution n0 is given by n0 equal to capital M1 into capital N1 small n1 into c1 plus capital M2 into small n2 plus into C2 plus dot 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 plus capital MR into small nr into CR, where MI is given by M1 into M2 dot 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 M into MR by MI, and the congruence MI equal to congruence to 1 mod modulo MI. Okay, so here the congruence are given by n congruence to 1 mod 7 in this problem, and n congruent to 4 mod 15. Okay, so here C1 is what? C1 is 1, and C2 is what? C1 is 1, C2 is 4. Okay, C1 1, C2 4, and M1 is what? 7, and M2 is what? M2 is 15. Now check GCD of 715 is what? GCD of 715 is 1. So we can use the Chinese remainder theorem. We can use the Chinese remainder theorem, because here said that if GCD of MI equal to 1, we can use the Chinese remainder theorem. So accordingly to Chinese remainder theorem, there will be the unique solution of n has the modulo M1 into M2, that means 7 into 15, that means 105. So solution will be modulo 105. So here capital M1 will be M1 into M2 by M1, that means M2, that means 15. Capital M2 will be M1 into M2 by M2, that will be M1, that means 7, and the congruence is given by what? Congruence is MI Ni equal to 1, congruence to 1 mod Mi. So for I equal to 1, it will be M1 N1 congruent to 1 modulo M1 is what? M1 is modulo M1, so it will implies capital M1 means 15 N1 congruent to 1 modulo small m1 is what? 7. So if you divide 15 by 7, you will get the remainder 1, so it will equivalent to N1 congruent to 1 mod 7. So you can select N1 is small n1 is what? 1. So we take N1 is 1 here. Okay, so for I equal to 2, what we get? I equal to 2 M2 N2 congruent to 1 mod M2. What is M2 here? M2 is 7, and C2 is M2 is 7, and small m2 is 7 into congruent to 1, and small m2 is what? Small m2 is 15, so congruent to mod 1 mod 15. Okay, so here we multiply 13 to both sides, so we will get 91 into congruent to 13 mod 15. Now if I divide 91 by 13, we will get if I divide 15 by 50, if I divide 91 by 15, we will get remainder 1, so it equivalent to N2 congruent to 13 mod 15. Okay, so in this case we can take solution N2 equal to 13. Now see, the solution can be written as what? Solution can be written as N0 equal to M1 N1 C1 plus M2 N2 C2. So here the solution N0 will be M1 N1 C1 M2 N2 C2. So M1 is what? Capital M1 is 15 into capital M1 is 15, and small n1 is what? 1, and C1 is what? 1. So 15 into 1 into 1 plus capital M2 is what? Capital M2 is 7 into small n2 is what? 13, and C2 is what? C2 is 4. So if you calculate, you will get this 379. Okay, so the solution will be solution will be n congruent to 379 modulo 1 modulo what modulo 105 modulo 105. So modulo 105, this is the solution of the given congruence. Okay, so now if you divide 379 by 105, you will get 15315. So 4 6, so it will equivalent to n congruent to 64 mod 105. So in this case you also get the solution as n equal to 64. So if you do, you get same solution in both procedure. So here n equal to 64 also is solution. Similarly, you put the same way in every option, you will get the correct option. So 1 and 3 option are correct. Thank you for watching this video. Thank you very much.